Let's study shell sort. Shell sort, made by Donald Shell, was one of the first algorithms to break the quadratic time barrier. Shell sort works by comparing elements that are distant. This distance decreases as the algorithm runs until the last phase, where adjacent elements are compared. You can think of shell sort as long-distance insertion sorts. Here are sample codes for shell sort. This is another one. Don't let the multiple nested loops fool you into thinking that this runs in O of n cubed or O of n raised to 4. If you look closely, you can see the insertion sort within the code of shell sort. As you can see, these two nested for loops, this is actually the code for insertion sort. Shell sort uses a sequence h of 1, h of 2 to h of t called the increment sequence. Any increment sequence will do as long as h of 1 is equal to 1, or the last pass. This increment sequence is more like a decrement sequence because you start with the highest value, then you go down to the smallest, which is 1. For each pass, using an increment h of k, or the gap, we sort each element space h of k units apart, that is, a sub I minus h of k is less than or equal to a sub I. For now, we'll use Shell's increment, which is h of k is equal to the floor of n over 2, or integer division, n divided by 2. Further iterations of Shell's increment will be decreased using h of k is equal to the floor of h of k over 2, or simply h of k over 2 integer division. Let's try sorting this using shell sort. Let's switch to Excel, Microsoft Excel, for us to demonstrate better. So this is our original array. So we have 14, 18, 19, 37, 23, 40, 29, 30, and 11. Now, in order for us to sort using shell sort, we first have to get the gap, or the increment sequence. Our initial increment sequence is n over 2. So in our case, that's what? Take note that this is integer division. So we have 9 elements, so that's 9 over 2. Let's put that here. 9 over 2, and that's 4. So our initial gap is 4. Let me just copy paste this here. Okay. So what the main idea of shell sort is to do long distance insertion sorts. So we'll start here. Okay, and then we'll count 1, 2, 3, 4 elements rather, apart, like so. And then think of this as insertion sort, where we compare this element with this element. It's as if we are trying to insert this to this. Does that make sense? Anyway, so we ask the question, is this element less than this? If yes, we swap. Otherwise, we go to the next one. So we compare, is 23 smaller than 14? No, so we don't swap. And then we go to the next one. So let's copy paste it here. Rather cut, like so. So next we compare this with this. So as you can see, it's 4 elements apart. 1, 2, 3, 4, or 1, 2, 3, 4. So that's our gap. So is 40 smaller than 18? No. So what we do is we go to the next one. So we're now here, and then we compare it 4 units or 4 elements to the right. 1, 2, 3, 4. Is 29 smaller than 19? No. So again, we don't do anything. So we go to the next one. So is 30 smaller than 37? So again, it's as if we're doing insertion sort. So we compare this to this. Yes, it is. So we swap. 30, 37. And then we're not done yet. Technically speaking, we still have to compare this with the element, 4 elements to the left of 30. 1, 2, 3. But since there isn't one, that will be a break, or that will stop there. And next, we'll go to the next. Okay, is 11 smaller than 23? Yes. So we swap 11, 23. And again, after swapping, we compare this to the element 4 units to the left, 4 elements to the left. So 1, 2, 3, 4. So is 11 smaller than this guy here? Let's mark that with an asterisk, like so. Is this one smaller than this? That's a yes, so we swap it. So 11 and 14. And if we reach the end of this array, we'll stop, and that will be our initial pass. That will be the first pass, pass number 1. Next. So we'll do that again, but this time we'll have a smaller gap, or h of k. So this time we'll just simply divide our previous gap with 2. So 4 divided by 2, integer division, so we'll get 2. So our next gap is now 2. So let me just copy paste this here. Okay. And then we do that again. So we compare this one with the element to the left, to the right rather. 1, 2. But this time 2 elements to the right. Or you could have this one and then 2 elements to the left. So we compare that. Is 19 smaller than 11? That's no. So we go to the next one. Is 30 smaller than 18? No. So we go to the next one. That will be a break in the code. Is 14 smaller than 19? Yes. So we swap 14 then 19. And then again, we're not done yet. We compare 14 with 1, 2 elements to the left. Is 14 smaller than 11? No. So there'll be a break also. Next. Okay, is 40 smaller than 30? No. So we go to the next. Is 29 smaller than 18? No. So we go to the next. Is 37 smaller than 40? Yes. So in that case, we swap 37, 40. But again, we're not done yet. We compare 37 after swapping. We compare 37 with 1, 2 elements to the left. Is 37 smaller than 30? That's a no. So that'll be a break also. Next. Okay. That'll be the final one because we reached the end of the array. Is 23 smaller than 29? Yes, so we swap 23, 29. But again, we're not done yet. We compare 23 with the element to the left, 2 units to the left. 1, 2. It's not smaller than 23. 19 is not smaller than 20, so we stop there. And this should be our pass number 2. And for the next pass, we'll again divide this gap with the previous gap with 2. So that's 2 divided by 2, integer division, and that's 1. Now because we reached 1, that means that this will be the last pass. And in that case, this will just be insertion sort. This will be regular insertion sort. So think of it like this. So our gap is 1, so 11 and 18. Is 18 smaller than 11? No. We go to the next one. Is 14 smaller than 18? Yes, so we swap. Is 14 smaller than, again, we're not done yet after swapping. We compare 14 with 11. Is 14 smaller than 11? No. On to the next one. Is 30 smaller than 18? No. Is 19 smaller than 30? Yes. So 19 and 30. Again, we're not done yet. Is 19 smaller than 18? No. So go to the next. Is 37 smaller than 30? No. Go to the next. 23 smaller than 37? Yes. So we swap 23, 37. And again, we're not done. We compare 23 with 30. Is 23 smaller? Yes. So we swap 23, 30. And again, we're not done. We compare 23 with 19. Is 23 smaller? No. So we go to the next. So as you can see, it's just regular insertion sort at this point because our gap is just 1. Okay, continue. Is 40 smaller than 37? No. Oops, sorry about that. And the final one is 29 smaller than 40. Yes, so we swap 29, 40. We're not done yet. We compare 29 with 37. Is it smaller? Yes, 29, 37. Again, we're not done. Is 29 smaller than 30? Yes, so we swap. Again, we're not done. Is 29 smaller than 23? No. And we swap, and we stop rather. And because we're at the end, we reach the end, we stop there, and that's our third pass and final pass. And as you can see, it's already sorted. So that's how shell sort works. Going back to the slides. So again, this is our original array. Our gap will be 4. We'll end up with this, pass number 1. Our gap now will be 2. After that, we'll have pass number 2 here. Our new gap will be 1, so that's just regular insertion sort. So at the end, or the final pass, it should be sorted, like so. Okay, so I want you to try this on your own. See if you can use shell sort to sort this array. So make sure that you try shell sort before we go to the next part of the lesson.